Hello there, and welcome to Dreamy Science Stories. Tonight, we drift together into a quiet corner of the world, where the ocean breathes in long, unhurried waves, and the planet's hidden rhythms move softly beneath the surface. You don't need to do anything now. Just let your shoulders loosen, let the day melt gently away, and imagine yourself floating at the boundary where moonlight touches water. Far below that shimmering line, the ocean carries secrets. Warm currents that glide like silk, cold rivers that wander in the dark, and ancient pathways that circle the earth in slow, patient loops. These currents have been flowing for longer than memory, shaping climates, guiding life, and whispering through the deep, like stories passed from one tide to the next. Tonight, we'll follow those drifting paths. We'll let them carry us from glowing tropical waters to the quiet blue dusk of the open sea, and then deeper still, where the currents move like thoughts half dreamed. No rush, no effort, just a gentle journey through 100 soft, curious truths. And if these slow explorations ever bring you comfort, if they help your evenings unwind, or offer a peaceful way to end your day, you're always welcome to like, share, or leave a quiet comment. It helps other wandering minds find their way here too, one sleepy soul at a time. For now, just breathe and let the ocean begin. If you'd like, you can close your eyes for a moment and imagine the ocean not as a vast, unmoving sheet of blue, but as something alive, a world with breath, with pulse, with movement so gentle and ancient that it hushes the mind the way a lullaby hushes a restless child. Beneath its shimmering surface, the sea carries great rivers of water, not narrow streams, but broad, wandering giants, slow, patient, unbroken, ocean currents, soft-spoken travelers drifting through the deep. Some glide quickly, like a swimmer, slicing through calm water with practiced strokes. Others move with a quiet slowness, drifting as if half dreaming, their pace matching the long, unhurried rhythm of a creature that has known eternity. And though they seem effortless, these wandering rivers follow beautiful, delicate forces. Winds brushing the surface, the gentle turning of the earth, differences in warmth and weight that coax some waters upward and persuade others to sink into the blue below. Together, these influences shape the paths of the currents, paths that do not rush, but unfold like slow spirals across the planet. Warm currents float nearer to the sunlight, carrying tropical breath with them. Cold currents, heavier and quieter, slip downward into the darker layers of the sea. Some drift across entire oceans from one horizon to another, never pausing, never losing their way. Sometimes they divide into branching streams. Sometimes they merge again, joining like old friends meeting at a quiet shore. Sometimes they curl into swirling eddies, circles of water that turn gently, patiently, like the slow spinning of a silver coin before it settles. And then there are the grand loops, great belts of water that wander around entire basins, circling continents with the persistence of something that remembers paths older than human time. These loops move heat, move life, move stories from one corner of the ocean to another. They shape the climate more deeply than we ever notice in our day-to-day lives. While we watch clouds and winds and seasonal rains, the currents below are quietly guiding the warmth of the world. From the glowing equator, they carry gentle heat toward the cold stillness of the poles. And from the ice-touched regions of the north and south, they bring cool shadows downward into the tropics, where the sun's touch is strong. In their endless motion, they soften the extremes, never letting the equator burn too hot, never letting the polar seas freeze beyond return. Like caretakers moving with slow devotion, they help the earth stay balanced, temperate, and alive. Imagine them this way: great swirling conveyor belts, carrying warmth and cold, carrying memories of distant places. The waters that drift past an island in the Pacific may have once traced Arctic shores. The waters brushing against a quiet beach in Europe may have begun their journey beneath a blazing tropical sun. These currents are, in many ways, the glue of the planet's living systems. Without them, weather would be harsher, seasons more severe, the air less gentle. Entire ecosystems would unravel, losing the steady nourishment that has supported them for millions of years. Some currents are remarkably faithful. They follow the same pathways century after century, like a lullaby whispered over generations. Others shift with the seasons, responding softly to changes in wind and temperature, adjusting their course the way a traveler adjusts to the slope of a road. A few have a strength that is almost startling. Their flow can push drifting boats miles from where they began, carrying them across unseen highways that stretch far beyond the horizon. Yet other currents are so faint that a leaf resting upon them might move only inches in an hour. But even these quietest streams matter, for they help shape the way nutrients, heat, and tiny drifting organisms travel through the sea. And from far above, high above the clouds, from the calm, glassy silence of outer space, these currents can sometimes be traced as shifts in color, swirls of sediment, ribbons of greener or deeper blue, subtle patterns where warm and cool waters meet. The surface currents often follow the breath of the winds that blow season after season. In places where monsoon winds rise and fall, the waters rise and fall with them, turning, shifting, responding as if listening to a whispered instruction carried through the air. But deep beneath the sunlit skin of the ocean are the slower, heavier currents, the ones guided not by winds, but by differences in temperature and saltiness. These deep flows carve invisible roads through the darkness, connecting far-off basins, carrying dissolved minerals, ancient waters, and a long-traveled breath of the sea. Together, all these currents, fast and slow, warm and cold, shallow and deep, keep the planet from becoming too still, too quiet, too unchanging. They hold the Earth in gentle equilibrium, ensuring that warmth does not gather endlessly in one place, nor cold accumulate in another. They help the world exhale, and as they move softly, tirelessly, they weave invisible paths across the globe, paths that living things follow without ever fully understanding why. Paths that guide migrations, paths that feed life, paths that cradle the seasons, paths that let the earth rest in its own quiet harmony. If you listen closely, not with your ears, but with that quiet part of you that senses the world's deep emotions, you might feel the ocean's steady drifting beneath everything, a kind of ancient rhythm, a patience that has no equal on land. Some currents have been flowing along the same pathways since before the first forests rose on Earth. They have traced these routes calmly through ice ages, warm ages, quiet ages, and stormy ages, adjusting only gently, only when the world itself shifted around them. In their persistence, there is something comforting, an unbroken thread stretching through millions of years, reminding us that some parts of nature keep promises far longer than humans have existed. Yet other currents, more playful, shift with the seasons. As winds breathe in and out across the ocean's surface, the waters respond. They tilt, lean, stretch, and sometimes reverse direction, like dancers moving in time with a distant melody. Where the air changes, the sea listens. The currents feel this whisper and adjust their paths softly, gracefully, never in haste. And then there are the powerful ones, currents strong enough to pull drifting ships far from their intended course. Sailors long before modern navigation knew these currents intimately. They read the water the way others read the sky. A slight warmth, a sudden change in the texture of the waves, a difference in the color where two bodies of water meet. All of these were clues, signs of where the ocean wished to carry them. For a vessel caught in a fast-moving current, entire days of travel could pass without a single sail lifted. The sea itself would do the work, guiding the ship forward on its invisible road. These were the highways of water, shaped by forces too gentle for the eye, but too powerful to resist. But just as there are strong currents, there are gentle ones, currents so delicate that they move only a handful of meters in an hour, drifting with the softness of a feather floating through the air. On such currents, a leaf resting upon the surface might live out an entire afternoon, barely shifted from where it first settled. Yet even these subtle movements help stir the great mosaic of the ocean, preventing stillness, blending waters, carrying nutrients to places that would otherwise remain barren. From space, these movements leave whispers across the sea's surface, a swirl of pale green where sediment rises from the deep, a ribbon of darker blue where cold water brushes against warm, a curved line where two currents meet, forming a boundary as fragile as a strand of silk. These are the signatures of motion, soft but immense. Surface currents live in the sunlit layer, shaped by winds that sweep across the sea. When monsoon winds shift each year, entire regions of the ocean change direction, as if turning to listen. The water responds with a slow lean, a gentle slide, a sprawling curve that can reshape ecosystems for thousands of miles. But beneath this is another world. Far below the glittering skin of sunlight lies the deeper realm, the realm of heavy, quiet waters that move not in response to winds, but to differences in their own nature. Slight changes in temperature, small variations in saltiness. These tiny differences create weight, and weight creates motion. Warm, lighter waters rise, cold, heavier waters sink. And in this vertical dance, great deep currents are born. These deep flows glide through the ocean's darkness like ancient animals, slow, steady, unbothered by storms or seasons. They slip through underwater valleys, hug the slopes of unseen mountains, and travel through channels carved by Earth's restless crust long before the first humans walked on land. And along the way, they carry what the surface cannot: tiny grains of life, dissolved minerals, carbon that has been resting in the deep for centuries, nutrients that will someday rise again to feed blooms of plankton beneath distant sunlight. These deep currents stitch the ocean together from the bottom up. Without them, the sea would grow still and lifeless in its hidden layers. But with them, the ocean stays awake, alive with exchange, with renewal, with an endless cycle of rising and sinking that helps shape the very breath of the planet. Together, the surface and deep currents create a circulation so intricate that scientists sometimes call it the global conveyor belt. But to imagine it mechanically would be to miss its beauty. It is not a machine. It is a long, wandering exhalation of the sea, a slow, swirling breath that moves around the planet over centuries. A drop of water sinking beneath the North Atlantic might not re-emerge until it has crossed entire hemispheres, and when it finally rises, it may bring with it the memory of its long journey, its coolness, its minerals, its quietness, everything it gathered while drifting through the ocean's deep blue night. Through all of this, the currents protect the planet from extremes. They smooth the sharp edges of heat and cold. They carry warmth away from where it gathers too strongly. They bring coolness from where it has settled too heavily. They keep the equator from burning. They keep the poles from freezing. They let life flourish in places that would otherwise be harsh and unforgiving. Without currents, the Earth would be a world of stark contrasts, scorching in some regions, frozen in others, inhospitable to the soft, delicate web of life that stretches across its surface. But with them, the planet becomes a place of gentler gradients, where warmth and cold blend in quiet harmony. Currents also create invisible paths through the water, routes that traveling creatures have followed for millions of years. Salmon returning to ancient rivers, whales crossing from feeding grounds to birthing grounds, sea turtles drifting with predictable passageways on their long migrations. All of them move with help from these slow, sweeping arms of the sea. Even the smallest organisms, the drifting plankton that form the base of the ocean's food web, depend on currents to carry them to places rich in light or nutrients. Without these motions, life in the sea would not disperse, would not mix, would not cascade from one region to another with the ease that it does. And so, when we speak of currents, we are not merely speaking of water. We are speaking of movement, connection, balance, and breath. We are speaking of a system that has shaped the Earth quietly and continuously since long before humans learned the names of winds or seasons. In their ceaseless flow, the currents hold the memory of the planet, the warmth of the equator, the cool hush of the polar sea, the minerals of distant shores, the stories of storms that passed centuries ago. All of it drifts along these invisible rivers, and through their gentle exchange of heat, through their soft rearranging of waters, they keep the world from falling into harshness. They help preserve the delicate line between too hot and too cold. They cradle climates. They nourish life. They keep the earth breathing softly, steadily, continuously. The ocean's currents are not loud. They do not demand attention. They do not shout their influence across the sky. But they are always there, beneath ships, beneath clouds, beneath time itself, moving with quiet devotion, shaping the world with a patience that feels almost timeless. And if you ever find yourself standing at the edge of the sea, watching the surface shift in gentle strokes of blue and silver, you might catch the faintest sense of that ancient motion, the slow, comforting rhythm of currents beneath your feet, carrying the planet forward one soft breath at a time. If you imagine the ocean's currents as drifting thoughts of the planet, then the great ones, the truly vast, powerful, wandering rivers, are like the deep, steady breaths of the earth itself. They are grand in scale, patient in motion, and gentle in ways that only something ancient can be. Tonight, we drift alongside them, one by one, letting their stories unfold like slow-moving tides. Let us begin with one of the most famous travelers of all, the Gulf Stream. In the warm cradle of the Caribbean, where sunlight seems to linger a little longer than anywhere else, a ribbon of bright, shimmering water begins its journey. It slips between islands, gathers strength, and then stretches northward along the coast of North America. This is the Gulf Stream, the warmest and most powerful current in the North Atlantic. It moves with a kind of confident grace, swift but not hurried, immense but not harsh. As it travels toward Europe, it carries with it the memory of the tropics, soft warmth, pale jade hues, and the lingering breath of equatorial sun. When it finally arrives at the shores of Western Europe, it transforms everything it touches. Cities that should be cold and severe, places like London, Dublin, Bergen, and even faraway Trondheim, find themselves wrapped in a climate far gentler than their latitude deserves. The Gulf Stream is the quiet guardian of their winters, the unseen reason warm rain falls where snow should rule. And then far out at sea, its warmth slowly disperses, folding into the broader Atlantic like a sigh released into cool air. The Kuroshio Current. Across the world, on the far side of the Pacific, another great current flows, the Kuroshio. It moves past the coast of Japan like a dark silk ribbon, deep blue, almost black in certain light, earning its poetic name, the Black Tide. But its darkness is not ominous. It is rich, awake, a sign of depth and warmth, carrying tropical water northward along Japan's islands. Fisherfolk who have lived near these coasts for generations speak of the Kuroshio as if it were a living being, at times serene, at times quick-tempered, always alive. It feeds plankton blooms, guides migratory fish, and warms the shores of Kyushu, Shikoku, and Honshu with a persistent, gentle touch. Its path arches like a signature, curving eastward into the Great Pacific, where it eventually joins the waters of the North Pacific Current. In this way, it mirrors the Gulf Stream, two warm arms on opposite sides of the world, shaping the climates of continents with their leisurely sweep. The California Current. To the east of the Pacific, along the rugged coastline of California, the waters tell a different story. The story of coolness, clarity, and quiet fertility. The California Current flows southward, carrying cold, nutrient-rich water from the northern Pacific. Its movement is slower, more contemplative than the warm currents. There is no tropical shimmer here. Instead, the water is a soft, gentle grey-blue, like morning fog resting on the ocean's surface. Because it brings cooler water upward, life gathers along its path. Plankton drift in clouds. Sardines, anchovies, and salmon thrive. Sea lions follow these paths like familiar roads. Kelp forests rise from the coastal floor, nourished by the steady presence of cold water. The coastline of California, its misty mornings, its rolling fogs, its temperate climate, owes much to this quiet, steady current that moves as softly as a long exhale. The Humboldt Current. Farther south, along the spine of South America's Pacific coast, lies one of the most extraordinary currents on Earth, the Humboldt. Cold, abundant, and breathtakingly productive, it carries vast quantities of nutrients upward from the deep sea. In its wake, one of the richest ecosystems on the planet unfurls. Colossal fish populations, seabirds by the millions, playful sea lions, and drifting forests of plankton that glow faintly under starlight. The Humboldt is a bringer of life, a silent architect of abundance. And yet, its waters are humble, cool, muted, silvery. There is nothing flashy in its appearance, but beneath that modest surface, an entire world thrives, one that supports fisheries, wildlife, and even the climate of the surrounding land. The Agulhas Current. Now we drift across the world to the southeastern edge of Africa. Here, the Agulhas Current unfurls, a warm, swift ribbon sliding southward along the continent's coast. There is a boldness in its motion, a kind of dramatic flourish. The water is warm and clear, carrying the breath of the Indian Ocean in sweeping arcs. But what makes the Agulhas truly magical are the eddies it forms when it meets the colder waters of the Atlantic. Giant whirling rings spin off its edge, warm circles that drift into the open ocean like silent wheels, rotating for months, sometimes years. These eddies are so large that satellites can trace their spiraling shapes. They are the ocean's slow-motion storms, powerful but graceful, wandering through the sea with the poise of drifting galaxies. The Antarctic Circumpolar Current. And then we come to the greatest current of them all. At the bottom of the world, where frigid winds sweep across endless horizons, the Antarctic Circumpolar Current circles Antarctica in an unbroken loop. It is the mightiest flow on Earth. Vast, unstoppable, driven by winds that swirl around the planet's southernmost crown. It has no continents to block it, no shores to tame it, no boundaries to slow its path. It moves forever eastward, tirelessly, carrying waters from the Atlantic to the Indian, from the Indian to the Pacific, and back again. It is the belt that stitches the world's oceans into one, an endless, circling thread connecting all seas. Though the waters are cold, there is something soothing in their constancy. Their movement is the heartbeat of the Southern Ocean, a steady, silent pulse beneath the roaring winds. The Labrador Current. Returning north, we slip into the quieter embrace of the Labrador Current. Cold and calm, it carries Arctic waters southward along the coast of Canada, brushing against Newfoundland, and then drifting toward the northeastern United States. Its waters carry pieces of ice, echoes of polar silence, and a quiet, contemplative coolness. Where it meets the warm Gulf Stream, fog forms, soft, heavy, lingering like a curtain between two worlds. The dancing currents of the Pacific. Across the vast width of the Pacific, two great surface currents bookend the equator, the North Equatorial Current and the South Equatorial Current. The northern one flows westward, connecting distant islands, guiding sea turtles and drifting seeds across thousands of miles. The southern one mirrors its path, but belongs to the opposite hemisphere, forming with the equatorial countercurrent. a slow, spiraling dance of water. Where they swirl together, heat is exchanged, storms are born, and life blooms in moving patterns too vast for any single human eye to trace. Where the Pacific's twin equatorial currents sweep westward, another warm traveler follows the stretching curve of South America, one with a gentler temperament, the Brazil current. Along the southeastern coastline of Brazil, the sea takes on a softer glow. Here, the Brazil current moves like a warm breeze, translated into water, slow, bright, meandering after the forceful sweep of other great currents. Sometimes its path is smooth, sometimes it meanders with curls and loops, as though tracing the soft contours of the continent beside it. Its warmth nurtures life in the southern Atlantic, and its lazy drift softens the climate of coastal lands, warming beaches, coral thickets, and the hazy, sunlit shallows that cradle tropical fish. It is a current that feels almost like a lullaby, unrushed, untroubled, drifting as though it has nowhere in particular to be. But as the Brazil current moves south, something changes. It meets another force entirely. The Benguela current. From colder latitudes, the Benguela current rises with a kind of quiet authority. Its waters are cool, dense with nutrients, and startlingly alive. Flowing northward along the coast of southwest Africa, it brings with it the deep sea's hidden riches, fertile waters that give birth to one of the world's most productive marine ecosystems. Where the Brazil current is warm and gentle, the Benguela is crisp, steady, and richly generous. It feeds blooms of plankton so vast they can tint the sea green. It supports fish populations that feed birds, mammals, and entire coastal communities. It cools the air, shaping the desert landscape just inland, helping craft the foggy mornings that drift across the Namib Desert like ghostly veils. These two currents, the warm Brazil and the cool Benguela, never clash directly, but the contrast of their natures shows just how varied the ocean's great rivers can be. Each has its own personality, its own way of whispering through the world. The West Australian current. Far across the sea, along the coast of Western Australia, another cool current flows downward. The West Australian current is slow, almost sleepy, as if the long, straight coastline invites a simpler pace. Its waters are cool, but not cold, moving with a gentleness that belies the transformative influence it carries. Because it brings cooler water northward, the surrounding land becomes drier, shaping entire ecosystems along the shore. The sands that stretch into the horizon, the vast, sunburned curves of the Australian deserts, are partly born from this quiet, steady movement of the sea. The West Australian current does not hurry. It drifts, it cools, it shapes, it rests. Its softness is part of its power. The East Australian current. But on the opposite side of the continent, the ocean tells a very different story. Here, the East Australian current, famous to many from Finding Nemo, sweeps southward with bright, warm energy. It is fast, lively, and unmistakably warm. In its presence, the water glows turquoise and gold, and the surface seems to dance with sunlight. This current carries tropical warmth down the eastern edge of Australia, weaving through coral reefs, skimming past islands, and shaping the life of the Great Barrier Reef. Turtles ride it, fish drift along its pathway, Even the corals depend on the warmth it delivers from the north. Though it is nowhere near as large as the Gulf Stream, the East Australian current has a spirited charm of its own, an underwater river that seems to laugh as it runs. The hidden wind rivers of the Southern Ocean. In the cold waters circling Antarctica, the sea moves in ways that feel almost otherworldly. Here, strange circular flows, eddies and spiraling wind-driven currents spin across the water like slowly turning galaxies. Some of these swirling forms are so powerful, so persistent, that oceanographers sometimes call them water winds, currents so shaped by the atmosphere above that they mimic the restless turn of Southern Ocean storms. They rise, they fall, they swirl in mesmerizing patterns, each one like a quiet whirlpool in the middle of a world of ice. And though the Southern Ocean is harsh to humans, the currents it hosts are profoundly important. They connect the deep waters of all three major oceans, exchange heat between hemispheres, and stir nutrients that would otherwise remain trapped in the planet's coldest realms. The Somali Current. On the opposite side of the world, along the Horn of Africa, lies one of the most unusual currents on Earth, the Somali Current. Unlike most currents, which flow consistently in one direction, the Somali Current changes its mind with the seasons. When the monsoon winds shift, so does the sea. For part of the year, the current flows northward. When the winds reverse, it flows southward. This seasonal transformation gives the Somali Current a rhythm unlike any other, a rhythm tied not to latitude or temperature, but to the deep breath of the atmosphere itself. Its waters rise, fall, reverse, and renew, creating fertile upwellings that feed countless marine creatures and nurture coastal life. It is the ocean's version of seasonal migration, an entire river of water changing direction as though turning the page of a long, ancient book. Where currents meet. All across the world, there are places where currents brush past one another, soft boundaries between warm and cold, fast and slow, shallow and deep. And in these meeting places, something magical happens. Life gathers, because where two currents meet, nutrients rise from below. Where cold meets warm, plankton bloom. Where fast meets slow, drifting organisms accumulate. Where the ocean stirs itself gently, entire food webs awaken. These regions become corridors of life, highways where fish migrate, where whales feed, where seabirds wheel overhead in spiraling flocks. The ocean's edges, its borders between currents, are its most fertile realms. Sometimes the meeting of currents creates fog. Sometimes it creates vast swirls visible from space. And sometimes, quietly, it shapes weather patterns that ripple across continents. Where currents disappear, but currents can also fade. When they meet underwater mountains, they may split and vanish. When they encounter coral reefs, they slow and break apart. When they reach continental shelves, they might sink or turn aside, melting into the broader fabric of the sea. These quiet disappearances are not failures. They are transformations. The water simply finds a new path, because the ocean is never still, and every ending is merely a beginning of another slow drift elsewhere. The personalities of currents. And so, as we drift through the great rivers of the sea, we begin to understand something subtle. Each current has a personality. Some are warm and generous, carrying tropical softness to distant places. Some are cold and disciplined, bringing nutrients and clarity. Some are steady, calm, and ancient. Some are impulsive, seasonal, quick to shift. Some swirl in playful eddies. Some march straight ahead, unwavering. Together, they shape the living world. Together, they hold the climate in gentle balance. Together, they form the ocean's unending dance. In their movement, we see not chaos, but harmony. A harmony so immense, so soft, so enduring that it can only be felt fully when we slow down, listen deeply, and allow the ocean's stories to move through us like a distant, drifting tide. Far beneath the shimmering skin of the sea, far below the drifting tides and the dancing play of sunlight, the ocean becomes something else entirely. Still, shadowed, endlessly patient. It is here, in this vast blue dusk, that the deep currents live, the slow-moving rivers that form the ocean's hidden heartbeat. They do not hurry, they do not shimmer. They move with a slowness so profound that time feels different in their presence, almost heavier, almost softer, as if each moment stretches into a long, gentle sigh. Scientists often call this deep movement the thermohaline circulation, but names fade quickly in the quiet of the abyss. Down here, it feels less like a system and more like a drifting memory, an ancient loop of water that has been circling the earth since long before human stories began. It starts in places where the ocean becomes cold enough and heavy enough to sink, near Greenland, near Antarctica. In those high-latitude waters, winter breathes across the sea, cooling the surface and nudging it toward stillness. As the water cools, its weight deepens, and one day, quietly, without splash or sound, it begins to sink. Picture it, a slow, downward drift, like a feather settling toward the floor, but with the weight of entire seas behind it. This sinking water doesn't fall fast. It settles. It folds downward. It slides into the deep. Layer by layer, it sinks past the pale blue of the upper ocean into darker shades and darker still until the world turns nearly black. In time, this cold, heavy water joins the deep ocean currents, those long, shadowy rivers that wander the planet's underwater valleys. Their speed is astonishingly gentle. Some move only a few centimeters in an entire second. In the time it takes you to breathe once, a deep current has drifted just a handful of inches. But slowness does not mean insignificance. These currents are the great carriers of the ocean's secrets. They hold nutrients, iron, nitrogen, phosphorus, drawn upward from decaying life. They carry carbon dissolved from the atmosphere, storing it in the deep for centuries. They hold the breath of past climates, the whispers of ancient storms, the chemical traces of sunlight that touched the surface hundreds, even thousands of years ago. A single parcel of water can take centuries to complete the deep ocean loop. Some take 1,000 years. Some take even longer. Imagine that. A drop of water sinking near Greenland today may not rise again until long after entire civilizations have come and gone. In this immense journey, the deep currents keep the ocean from growing stale or stratified. Without them, the sea would separate into layers, warm above, cold below. never mixing, never sharing, never renewing. Life would wither, nutrients would settle and stay settled. The ocean's breath would slow, and eventually, so would the Earth's. But with these slow, steady movements, the deep sea remains alive. It circulates, it exchanges, it remembers. In the Pacific, the deep waters are older, so old that they've been drifting through the abyss for centuries. They carry more dissolved carbon, more nutrients, more shadows. They are called aged waters, though age down here is not a burden. It is simply a story, one written slowly, patiently, like sediment settling on the sea floor. Sometimes the deep currents pause. Water may linger in underwater basins for decades, sitting quietly, untouched by surface winds or sunlight. Then, one day, perhaps nudged by a shifting circulation pattern, it begins to drift again, moving through shadowed trenches like a ghostly wind, brushing past rocky ridges and ancient volcanic slopes. These deep paths are not smooth. They twist through underwater mountain chains. They squeeze through narrow gaps called sills, where the water accelerates like a whisper, turning into a low hum. Some flows slip beneath layers of warmer water above, out of sight from anything living at the sunlit surface. They move unseen, unfelt, but always present, an entire hidden world flowing beneath another. This great circulation influences more than the ocean itself. It shapes the climate. It decides how much carbon the sea can store. It regulates the exchange of gases between ocean and air. When it strengthens, the world cools. When it weakens, the world warms. And if it ever falters significantly, Europe could become far colder than it is now. Its winters sharpened, its summers softened, its seasons shaped by the quiet turning of water thousands of kilometers away. Every change in the deep ocean takes decades to reveal itself. These currents do not rush. They do not answer quickly to the world above. They respond slowly, thoughtfully, as though each shift must be considered, absorbed, softened, before the ocean allows itself to change. In this way, the deep currents act as Earth's long-term memory. They hold not only the ocean's past, but echoes of its future. What sinks today will resurface far beyond our own lifetimes, carrying with it the imprint of this moment, its temperature, its carbon, its quiet story. This hidden circulation is the ocean's great equalizer, the force that keeps waters from remaining trapped in isolation. It ensures that nutrients do not settle forever in darkness. It prevents the sea from becoming a layered world of silence. It keeps everything in gentle motion, even the places where no light can reach. It is the planet's softest, slowest, deepest breath. The deeper we drift into this quiet world, the more its rhythm begins to feel familiar, slow, deliberate, almost meditative. There is no hurry here, no sudden movement, only the steady, ancient drift of water that has been traveling since long before our first ancestors gazed at the sea with wonder. Deep beneath the surface, water moves with the softness of thought, like an idea forming slowly in the back of the mind. It nudges forward, curves around unseen mountains, pauses in wide basins, and gathers strength in narrow passages carved by time and pressure. These pathways are older than continents, older than the shapes of coastlines. Some were formed when the world was still young, when the ocean was a different place entirely. And though the deep ocean is dark, it is not empty. Life exists here, in forms so delicate and patient, they seem part of the water itself. Lanternfish, drifting like tiny stars, soft-bodied creatures pulsing gently through the blackness, crabs and worms crawling along the seafloor with slow persistence. All of them rely on the nutrients carried by the deep currents, the steady rain of organic matter from above, and the rich mineral traces brought from faraway waters. Without the deep circulation, life in these shadows would fade. Without the transport of nutrients, even the sunlit surface would starve. The ocean's quiet conveyor is the bridge between these two worlds. As these slow waters drift from one basin to the next, they carry dissolved carbon, silent, invisible, and essential. The deep ocean is Earth's greatest storehouse of carbon, holding it tightly for centuries at a time. Every parcel of water that sinks brings with it a fragment of the atmosphere, trapping it far below where it cannot warm the sky. This is one of the ocean's greatest gifts, its ability to hold the planet's breath, to soften the impact of change, to keep the world from warming too quickly. But it is also a fragile balance. When climate shifts above, the deep circulation feels it, slowly, quietly, but inevitably. A warmer world can slow the formation of cold, sinking water near the poles. A fresher surface can make it harder for water to descend. And when these patterns shift, the entire deep network responds. If the deep currents weaken significantly, the effects ripple outward like a long, slow wave. Europe cools. Monsoon patterns shift. The atmosphere's breath becomes unsteady. Even ecosystems thousands of kilometers away feel the tremors as nutrient cycles and temperature patterns adjust to the new rhythm. But the deep ocean does not break easily. It adjusts, it waits, it absorbs, it moves with the patience of something that measures time not in years, but in centuries. In the Pacific, the deep waters whisper of age. They have traveled to so far for so long that they carry the trace of countless seasons. Their carbon content is higher, their nutrient content richer, their memory deeper. These waters drift like old travelers who have seen too much to speak quickly. Everything about them is slow, careful, unhurried. Some parts of the deep ocean are nearly still. Waters that sit in quiet pockets behind underwater ridges, unmoving for decades. They wait like pools of dream water, untouched by the world rushing above. Then, with a subtle shift in the global circulation, they are lifted and carried onward, joining the long, slow march of the deep conveyor once again. It is almost like listening to the ocean breathe in its sleep. A slow inhale as water sinks, a long exhale as it rises centuries later, a silent pause in between. And though the deep currents are invisible to the human eye, they are as real as the tides, as essential as the winds, as constant as gravity. They thread the planet together from below, tying far-off seas into a single vast breathing system. In some places, these deep currents race through narrow passages with surprising speed, still slow by surface standards, but swift in the language of the abyss. They squeeze through canyons, they tumble over seafloor ridges, they curl around volcanic slopes. These are the ocean's hidden windstorms, the water winds of the deep, that no light can reveal. Above them, a warm layer of water rests, unaware of the slow, powerful river traveling just below. Swimmers, ships, storms. None of them feel this motion. It continues without fanfare, without announcing itself, without ever breaking the surface. This is the deepest secret of the sea, that beneath the warmth and sparkle of the upper layers lies a solemn, ancient world of motion. A world where water moves not in waves, but in long, sweeping journeys that span continents. And in this motion lies equilibrium. If the ocean were left still, if its waters refused to mix, the world would fracture into extremes. The surface would grow too warm, the deep would grow too stagnant. Life would lose its balance. But with these currents, the earth remains whole. They prevent the ocean from splitting into layers too sharply divided. They keep cold and warm in gentle conversation. They allow nutrients to rise and carbon to settle. They hold the world in a quiet, steady calm. In the end, the deep ocean circulation is not simply a pattern of water. It is a story of patience, a tale told in slow drifts and soft exchanges, a reminder that the most important movements in life are often the quietest ones, the ones that happen far beneath the surface, unnoticed but essential. And as we drift back upward, toward the lighter blues of the surface world, it's comforting to remember that beneath every wave, beneath every tide, beneath every ripple, the deep ocean continues its ancient journey, carrying the memory of the world in its silent, steady flow. A whispering river that never stops moving, never stops breathing, never stops holding the earth in its gentle arms. If you lean your imagination gently toward the sea, quietly, the way you might lean toward a whisper, you will begin to sense something subtle, something delicate, flowing beneath every moment of life in the ocean. It is the touch of the currents, not only rivers of water, but rivers of life. They do not simply move water from one shore to another. They carry ecosystems, migrations, futures, and entire worlds hidden in drifting light. Tonight, we follow these living streams, the drifting world of plankton. In the sunlit skin of the sea, where the water glows with soft turquoise light, millions of tiny drifters float. Plankton, as fragile as dust motes in a sunbeam. They drift not by choice, but by nature, moving wherever the currents carry them. And yet, these small wanderers are the foundation of life. As the currents roll forward, they gather plankton in slow, shimmering clouds. Green, where phytoplankton bloom. Purple-blue, where zooplankton pulse with faint bioluminescent sparks. These drifting swarms feed fish, whales, coral reefs, and entire chains of life. Everywhere a current flows, it brings with it nourishment, like a traveling market of energy for the open sea. In this way, the currents do not merely transport life, they shape it. They choose where abundance settles, where scarcity lingers, where future generations will flourish. Sea turtles and their wandering roads. And then there are the sea turtles, ancient travelers with calm, knowing eyes. For them, the currents are not just pathways, but companions. A turtle born on a warm beach might one day slip into a gentle current and ride it for thousands of kilometers, crossing oceans without fear. They conserve energy this way, letting the water cradle them, guide them, carry carry them like a slow rocking lullaby. Green turtles, loggerheads, leatherbacks, each one follows these flowing roads, sometimes returning decades later to the very shore where their life began. And when they sleep, drifting lightly near the surface, it is often a warm current that keeps them comfortable, holding them like a soft quilt beneath the stars. Whales resting in warm eddies. Far below, giant shapes move through the blue. Whales, the quiet singers of the deep. Though they travel with purpose, they are also creatures of rest. Warm eddies, spun off from stronger currents, form gentle pools of circulating water. Inside these soft spirals, the temperature is slightly warmer, the water calmer, the world more serene. Here, whales sometimes pause. They allow themselves to drift. They let the warmth seep into their massive bodies. Between long migrations, they treat these eddies like rest stops, quiet havens where the sea hums softly around them. Imagine a whale floating inside a vast, slow-moving circle of warm water, the sunlight filtering down in faint silver shafts. It is a moment of stillness inside the endless journey. Where fish gather, the boundaries of the sea. Many young fish, delicate and translucent as fresh glass, gather near the boundaries where two currents meet. These edges are rich places, zones where nutrients rise, where plankton bloom, where the sea becomes a well-stocked nursery. Here, food is plentiful. Here, safety is possible. Here, the next generation feeds and grows. It is at these borders that life explodes in color. Schools of tiny fish shimmer like quicksilver. Larger fish weave through the currents like silver strokes of ink. Predators patrol nearby, sensing opportunity. And yet, there is balance, a lively, shifting tapestry of creation and survival. Coral's children on the ocean roads. Corals, though anchored in place, are not confined. Their young, their tiny, drifting larvae ride the currents out into the open sea. They float like pollen on the ocean's breath, light and hopeful, searching for a home. A current may carry coral larvae across islands, reefs, continents. Some drift only a short while. Others may travel hundreds of kilometers before settling into a crevice where light and shadow meet in perfect harmony. In this way, coral reefs are connected across the world, not by land, not by sight, but by the gentle hand of ocean currents, spreading life like seeds on the wind. Cold currents, makers of life. Where cold, deep waters rise toward the surface, something extraordinary happens. Nutrients long trapped in the shadows return to the light, and the ocean blooms. Fish gather in great silver masses, sardines, anchovies, herring, each moving like a single shimmering organism. These regions are so rich that they sustain entire food chains, seabirds circling overhead, seals weaving beneath, dolphins striking through shoals like streaks of quick mercury. This is why places touched by cold, nutrient-rich upwelling, like the California current or the Humboldt current, become some of the most fertile waters on Earth. Life follows the cold. Life follows the rising. The gentle pulse of jellyfish. Some jellyfish follow the currents completely, letting themselves be carried as though they were pieces of silk drifting in a slow breeze. Others respond to seasonal shifts, blooming in great numbers when the currents change direction or when warm water collects in certain regions. to see them from above, glowing softly just beneath the waves, is like watching a galaxy drift across the sea. Their delicate pulsing bodies ride the water without resistance, trusting it entirely, moving where the ocean desires. For them, the current is both transportation and destiny. Birds that hunt along the currents. Above the sea, where wind strokes feather instead of fin, seabirds follow the currents too, not by drifting within them, but by reading the signs they leave behind. Where a current brings nutrients to the surface, fish gather. Where fish gather, birds arrive, skimming, circling, diving with sharp cries that slice through the salt air. Albatrosses cross entire oceans with the help of these feeding lanes. Terns find their prey where cold meets warm. Petrels trace invisible ribbons of rich water woven across thousands of kilometers. Even from the sky, the currents guide life. Invisible highways of oxygen. Many places where currents collide become fountains of oxygen. Water bubbling with dissolved breath. Large animals sense these places instinctively. Sharks glide through these oxygen-rich zones with calm certainty, their bodies efficient, their movements unhurried. Sometimes, a shark will rest in the moving water, letting the current push oxygen across its gills, spending almost no energy in the process, riding the flow like a quiet drift. Tuna, swift and muscular, follow these ribbons of oxygen too. They race along them like athletes on an endless track, weaving in and out of currents as if chasing the very breath of the sea. These highways of oxygen determine where life gathers, where migrations form, where the deep and surface worlds exchange their quiet messages. Where the currents touch the sea with gentle fingers, the ocean awakens. Where they shift and swirl, entire worlds respond. Life in the ocean is not scattered randomly. It gathers, grows, and migrates along these vast, moving corridors of water. And in the drifting pulse of the sea, each species finds its own rhythm. Sharks riding the silent flow. Sharks, for all their reputation as fierce hunters, are also creatures of extraordinary sensitivity. Beneath their sleek bodies lies an instinctive awareness of moving water, of its temperature, pressure, and breath. Some sharks slip into a current not to hunt, but simply to rest. Imagine a hammerhead or a blue shark drifting slowly in a broad ribbon of current, letting the flow push water across its gills. In this stillness, it hardly has to swim at all. The current replaces effort, the water becomes a cradle, and the shark moves forward, slowly, effortlessly, with the poise of something carved from fluid shadow. To save energy is to survive, and the currents, ancient and tireless, offer that gift. The silver schools, herring, anchovies, and the dance of abundance. In the cool waters where upwelling rises, where the deep sea exhales nutrients into the sunlit world, fish gather in astonishing numbers. Herring shimmer like ribbons of liquid metal. Anchovies churn in dense glittering clouds. Sardines move like a single living tapestry woven from countless small bodies. These fish depend on cold, nutrient-rich water. Where the currents bring such water upward, life flourishes. Where they do not, the ocean becomes quiet, sparse. A change in the direction or strength of a current can transform entire coastlines from thriving centers of abundance into quiet, empty plains of water. Generations of fishermen have known this intimately, their livelihoods tied to the invisible breath of the currents. But when the cold waters rise, the sea becomes a feast, life layered on life, each creature feeding the next in a cycle older than human memory. The warm touch that speeds growth, in the gentle warmth of certain currents, like the Gulf Stream, the Kuroshio, or the East Australian current, many young fish find something precious: heat. Warm water accelerates their growth. It increases their metabolism, fuels their tiny muscles, quickens their development. A young fish that might take months to grow in cold water may reach maturity in a fraction of the time within the embrace of a warm current. Here, the sea becomes a nursery with soft walls and generous light. Entire migrations are shaped by this warmth. Some species rise into these currents like children climbing into a warm blanket. They feed, they grow, they gather strength for journeys still ahead. Even the smallest shift in the temperature of a current can ripple through entire ecosystems, altering the pace at which life awakens and matures. Invisible travelers, bacteria of the deep. Not all life carried by the currents is visible. Some of it exists at a scale so small it slips through even the lightest nets. Microbes and bacteria that thrive in specific blends of temperature, salt, and minerals. Many of these microorganisms come from the deep ocean, where water is old, cold, and rich in carbon. As the deep currents rise, or as surface waters sink, these tiny travelers are carried across basins and continents. Some bacteria thrive only in water that has drifted through the deep circulation for centuries. They depend on ancient chemistry, on minerals dissolved in darkness, on temperatures near freezing, on the quiet stability of deep water. The currents carry them like spores of a hidden forest, scattering them through underwater canyons, lifting them into new realms, helping them colonize distant places. Though invisible, they are essential, the first link in many chains of life. Flying fish and the lift of the sea. Near the surface, where the sunlight warms the water into soft blues, another creature dances with the currents, the flying fish. These remarkable beings do not fly in the way birds do. They glide, and the currents help them. When a flying fish gathers speed, it uses the surface tension and the push of moving water to launch itself out of the sea. A small upward swell in a current can add just enough lift. A gentle wave riding atop a larger current can send the fish soaring through the air for dozens of meters, sometimes more. In the glow of dawn or dusk, their silver wings glimmer like quick strokes of light. They ride the wind for a moment, waterborne creatures tasting the sky before slipping back into the sea. Life reaching faraway shores. Currents are also great voyagers of life. They carry eggs, larvae, seeds of seaweeds, drifting jellyfish, tiny crustaceans, small travelers with no means of journeying on their own. These travelers may reach remote islands, coral atolls, volcanic shores rising from the deep, or drifting patches of floating kelp. And each arrival is a potential beginning, a new reef, a new colony, a new generation of life unfolding in a place it has never touched before. The sea, through its currents, scatters possibilities, and some of those possibilities take root, changing the map of life one quiet drift at a time. Drifting as a strategy. For many small creatures, drifting is not merely the result of being carried by currents. It is a strategy. Tiny crustaceans rise toward the surface at night, catching nighttime currents that carry them to new feeding grounds. Jellyfish larvae let themselves be swept into eddies that offer warmer temperatures. Starfish larvae ride currents toward rocky shores. Even some worms and snails rely on the sea's gentle hand to give their young a chance at survival. Drifting allows them to spread across oceans without wings, fins, or strength. It is a way of being carried by something larger, of trusting the world's natural flow. The great highways of whales. Whales, especially the humpbacks, have traveled the same ocean routes for thousands of years. These routes are not random. They follow warm currents that offer resting places, guiding flows, and rich feeding grounds. A humpback may begin in polar waters, feeding on dense shoals of krill. When winter approaches, it will follow a warm current toward the tropics, where the water is gentle enough for birthing. These warm highways allow whales to conserve energy during their long migrations. They follow the shifting bands of warmth, like invisible pathways laid across the sea. Imagine a whale, a creature larger than a bus, moving in perfect sync with a river of warm water that stretches for thousands of kilometers. There is something profoundly peaceful about this image, the vastness of the animal, the vastness of the water, both drifting toward the same distant destination. Tuna, the athletes of moving water. Tuna are among the strongest swimmers on Earth. Their sleek bodies are built for speed and endurance, but even they follow the currents. Tuna seek out flows that are rich in oxygen, where their muscles can perform at their peak. They chase along the boundaries of warm and cold waters, where prey gathers. They move with purpose, intelligence, and powerful instinct. To watch a school of tuna race alongside a current is to see energy itself made into motion, clean, bright, relentless, almost electric. They are the ocean's long-distance runners, using the world's moving water as both a guide and a source of strength. The nurseries within eddies. Sometimes, when a powerful current curls into a circular eddy, it creates a temporary sanctuary. Within the swirl, the water warms slightly, nutrients gather, and plankton bloom in slow, drifting spirals. These eddies become nurseries, cradles for tiny life. Larvae feed, juvenile fish grow. The swirling motion protects them from predators and from harsh, open sea conditions. A single eddy can nurture millions of young creatures, holding them gently until they are strong enough to slip back into the vastness of the sea. 40% of life carried by currents. In the end, when we step back and look at the ocean as a whole, a beautiful truth emerges. Nearly half of all marine life depends directly on the movements of the currents. 40% of the sea's entire web of existence, its plankton, its fish, its drifting larvae, its great migrations, its smallest bacteria, its whales, its travelers and wanderers and dreamers, is shaped by the slow, gentle, ceaseless flow of water. The currents are not merely physical forces, they are guardians of life, architects of ecosystems, silent shepherds guiding the living threads of the ocean from one horizon to another. Every creature, from the tiniest drifting speck to the largest singing whale, is touched by these movements, carried, nourished, guided, or sheltered by them. And when you listen closely, you can almost hear it, the soft, endless whisper of life being carried forward on the ocean's gentle breath. If you ever stand by the shore and feel the air soften against your skin, a quiet warmth drifting off the sea, or a cool breath rising gently from the water, you are feeling the touch of ocean currents. Not directly, not like feeling a wave wash over your feet, but through the air, through the weather, through the invisible patterns that wrap themselves around continents, shaping the moods of entire regions. For though currents move beneath the surface, their influence rises, spreads, and unfolds across the atmosphere like a long, slow exhalation. They are the hidden architects of climate, the gentle balancing of the planet. The Earth, left to itself, would lean toward imbalance. The tropics would grow endlessly hot beneath the heavy, direct sun. The poles would sink into deep cold, their temperature locked away like ice in a dark vault. But the ocean intervenes. Currents carry warmth away from where it gathers too strongly. They bring cold from where it settles too deeply. They smooth the jagged edges of temperature, blending heat and coolness into a more livable world. This is why Earth is not divided cleanly into burning and frozen zones. It is why the middle latitudes feel gentle seasons instead of brutal extremes. Currents are the soft hands leveling the scales. Without them, the planet would be harsher, stormier, far less kind. A warm gift to northern cities. Perhaps nowhere is this influence more visible than in the case of the Gulf Stream. Flowing from the glowing tropics to the cool North Atlantic, it carries warm water like a long ribbon of golden breath. When this warmth reaches Europe, it transforms everything it touches. Cities like London, Dublin, and Bergen exist in latitudes that, without the Gulf Stream, would feel closer to Labrador or northern Canada, places of harsher winds and deeper snows. And yet, these European cities are softened by warmth that has traveled thousands of kilometers by sea. The Gulf Stream is their quiet benefactor. It wraps the shores of Western Europe in a mildness they never earned from the sun alone. Imagine winter arriving, and yet the sea remains just warm enough to keep the air from turning severe. That is the work of currents, the fate of coastal climates. Around the world, many coastal regions owe their character not to land, not to latitude, but to water. Some areas become fog-bound and cool because a cold current slides past them. Others are humid, lush, and rain-soaked because a warm current lingers offshore. A coastline near warm water may feel tropical, even at higher latitudes. A coastline near cold water may feel dry, crisp, almost desert-like, despite lying far from any desert on land. Currents sculpt these climates with the gentlest of tools. Not storms, not winds, not violent change, but the slow, steady motion of water moving through centuries. El Niño. When the ocean changes its mind. But not all influences are gentle. Sometimes the ocean shifts its pattern and the entire world feels the change. Along the Pacific coast of South America lies a current so cold and so rich with nutrients that life flourishes wildly in its presence. But every few years, this cold flow weakens. warm water from the western Pacific drifts eastward, settling like a blanket over the normally chilled coastline. This is El Niño, and when it arrives, the atmosphere responds. Rain patterns shift across continents. Some places flood, others dry out. Fisheries collapse temporarily. Storm seasons reorganize. Even distant regions, Africa, North America, Australia, feel its touch. El Niño is the ocean speaking in a louder voice than usual. La Niña, the ocean's cool return. In time, the cold water often returns with force. The upwelling strengthens. The eastern Pacific cools more than normal. Trade winds grow steady and firm. This is La Niña, the cool sibling of El Niño. During these periods, rainfall increases in some regions and decreases sharply in others. Storms may quiet in places and intensify elsewhere. The ocean shifts back and forth like a sleeper adjusting their weight, slowly, heavily, but with consequences that echo across the world. The sky that changes with the sea. One of the clearest signs of the ocean's influence on weather comes from the places where cold water meets warm air. Here, fog blooms, soft, thick, ghost-like. The air cools against the cold current. Moisture condenses, and a mist forms that can linger for hours, days, or weeks. Sailors once navigated by the presence of such fog, knowing that its grey veil whispered of cold currents beneath the hull. Coastal towns grew accustomed to its slow arrival, the way it muffled sound and softened the world into a quiet palette of pale greys and blues. Fog is the ocean reaching into the sky, storms fed by warm waters. But warmth can do more than soften winters or create gentle breezes. Warm currents carry energy that the atmosphere can draw upon. A hurricane, gathering itself above the warm seas, feeds on this heat. Like a fire taking fuel, the storm intensifies where the water is warmest. A warm current can nourish a storm, allowing it to grow, strengthen, and spin with greater force. And so, even in the ferocity of hurricanes, the fingerprint of currents remains. Cold currents, dry air. Cold currents do the opposite. They cool the air above them. Cold air holds less moisture, and so regions above cold currents often become dry, not only at sea, but on land as well. A coastline with a cold current offshore may receive far less rain than one might expect. This is why deserts form beside oceans in places like Namibia, Chile, and Baja California. The land is not lacking water, the air is. Where warm and cold waters meet, the sky listens. Where currents strengthen or weaken, winds shift. Where the sea adjusts its quiet rhythm, the air above it rewrites its patterns. Even the smallest changes ripple outward, touching seasons, shaping rain, altering the subtle balance that life depends on. Because the ocean is not separate from the atmosphere, it is the atmosphere's deep, slow heart. When a small change becomes a great one, the currents of the ocean do not shout. They do not surge with sudden fury, not the way storms do, not the way winds can. Instead, they change softly. A degree warmer here, a slight shift in direction there, a bit more cold water rising from the depths, a bit less warm water drifting from the tropics. Yet these small, whispered adjustments can shape entire decades of weather. A weakening of a warm current can cool continents. A strengthening of a cold current can alter monsoons. Even slight changes in the position of a current can redirect storms, change drought patterns, or influence the humidity of whole regions. Climate, though vast, is sensitive. It listens to the sea's quiet voice. Seas that rise and fall with currents. Most people think of sea level as simple. Water rises, water falls. But along coastlines, sea level responds to the push and pull of currents. Where a strong current hugs the shore, the sea surface may rise by tens of centimeters. Where a current weakens or drifts away, the water may quietly sink. These changes are gentle, slow, often unnoticed from day to day, but unmistakable across months and years. Sometimes two cities at the same latitude, on opposite sides of an ocean, have different sea levels simply because currents gather water against one shoreline and draw it away from another. It is the ocean's subtle way of redistributing weight, a slow shifting of blue. The ocean's rhythms across decades. Currents move in cycles. Some strengthen every few decades, some weaken, some oscillate between states of warmth and coolness, affecting rainfall, storm tracks, and temperature patterns across continents. These natural rhythms, the Pacific Decadal Oscillation, the Atlantic Multi-Decadal Oscillation, and others, are like the slow turning of pages in the ocean's ancient book. We do not always understand why a phase begins or ends, but we feel its presence in harvests, in droughts, in seasons that seem slightly off, in winters that come sooner or later than expected. The ocean does not rush. Its rhythms are measured in decades, even centuries. But each turn influences the sky we live under. A world without currents, a colder Earth. If we imagine the Earth without its ocean currents, without the warm ribbons that deliver heat northward, without the cold flows that carry coolness toward the equator, we imagine a planet far more severe. The equator would blister, the poles would tighten into deeper cold. The places in between, where so many people live, would swing between extremes, lacking the gentle smoothing that the ocean provides. Without the global transport of heat, Earth would be a sharper, harsher place. Its breezes less forgiving, its winters more biting, its summers more blistering. The ocean is our world's natural thermostat, a quiet regulator that keeps the skies soft enough for forests, fields, and families. Deserts born beside the sea. One of the ocean's most surprising influences lies in the creation of coastal deserts. Namibia, Peru, Baja California. These deserts rest beside cold currents, currents that cool the air so effectively that the air can no longer hold moisture. Rain becomes scarce, clouds thin. The land dries into quiet expanses of wind-shaped dunes. It's a paradox, a desert beside an ocean, but it makes perfect sense when we listen to the currents. A cold sea can withhold rain as easily as a warm one can summon it. Moisture carried on warm currents. Warm currents whispers a different story. They warm the air, which can then carry more moisture, and where moist air drifts inland, rain follows. Some coastlines remain lush, green, and humid not because of local rivers or forests, but because a warm current sits offshore, evaporating softly into the sky, feeding clouds with gentle insistence. A warm current is like a quiet engine for rainfall, steadily releasing humidity that eventually returns as rain over land, the interwoven breath of sea and sky. In every shift of wind, in every storm that gathers, in every morning fog or lingering drizzle, the ocean has played a part. Currents guide the motion of heat. Heat guides the motion of air. Air guides the motion of weather. And so, a current that changes by only a little can influence a storm that forms thousands of kilometers away. A cold upwelling on one coast can shape the rainfall on another. A warm stream of water can soften an entire winter. Weather is the sky's memory of the sea, a planet in quiet balance. When we look at the ocean, we may see only waves, foam, light dancing on the surface. But beneath that brightness lies a system delicate enough to shape continents and powerful enough to cradle the climate of every nation on Earth. The ocean's currents keep the world in balance. They distribute heat. They sculpt coastlines. They feed storms. They soften seasons. They breathe warmth into cold places and coolness into warm ones. Without them, Earth would be less livable, less gentle, less kind, less familiar. With them, the planet hums in a rhythm that has endured for millions of years, a calm, steady pulse, like the heartbeat of something vast and protective. And every breeze you feel, every raindrop, every fog-bound morning or mild winter evening is a quiet reminder that the sea is always speaking to the sky, and the sky is always listening. If everything in the ocean was steady, predictable, and neatly arranged, the sea would still be beautiful, but it would lack the quiet magic that comes from mystery, surprise, and the small impossibilities that drift just beneath the surface. Ocean currents are immense and ancient, yet full of unexpected quirks, little wonders that reveal the ocean's playful side, its secret habits, and its whispering stories. Tonight, we sink into that softer strangeness, those curious, dreamlike moments when the sea behaves in ways both delicate and astonishing. Not all currents are grand and sweeping. Some are small circles, eddies, that bloom into existence for just a few days. They swirl like faint galaxies in miniature, hardly larger than a distant island. They form quietly, often unnoticed, except by satellites or drifting creatures. And then, without drama, they fade, dissolving back into the broader water like dreams forgotten by morning. If you could hover above them, you might see a ring of slightly darker blue, or a faint curl of cloudiness where sediment is gently lifted. But often, you would see nothing at all. These tiny whirls are the ocean's passing thoughts, soft, temporary, ephemeral. Strange as it sounds, the ocean can gather floating debris into vast, drifting islands. Not solid islands, not anchored, not truly formed, but collections of plastics, nets, fragments of everyday life drawn together by the broad spinning arms of great ocean gyres. The North Pacific garbage patch, the South Atlantic accumulation zone, the Indian Ocean's drifting clusters, all are shaped by the turning of currents. The water does not intend to collect these things. It simply circles, and the lightweight fragments follow. Like dust settling in the corners of a room, these items gather in the quiet centers of oceanic loops. It is one of the ocean's more sorrowful surprises that its circular grace can gather human forgetfulness. Yet even these drifting islands whisper stories of how currents fold and curl, moving with patient, spiraling rhythms. For centuries, people have tossed bottles with notes into the sea, some out of hope, some out of curiosity, some simply to see where the ocean's hand would carry them. A bottle released in the North Sea may wash up in Canada. A bottle from Japan may drift to California. One from the Caribbean might appear years later on the shores of Ireland. Currents become the bottle's companions. They cradle the glass, roll it gently, pass it from one flow to another, and carry it across entire hemispheres until at last it reaches a distant beach. Every bottle found is a quiet reminder. The ocean is always in motion, always listening, always delivering forgotten messages back to land. It sounds almost fictional, but a single shoe dropped into the sea can travel the world. Researchers have tracked sneakers, sandals, even rubber boots lost from cargo ships or storms. Years later, one shoe might be found in Alaska, while its partner appears in Hawaii. Another might wash ashore in Chile or drift into the Arctic. These journeys are slow, unhurried, and astonishing in their distance. A shoe has no sail, no motor, no navigation, only the quiet guidance of currents. It is carried like a passenger, lifted by eddies, drawn into gyres, released along shorelines thousands of kilometers away. Even something as humble as a sandal can reveal the global reach of the ocean's drifting roads. Humans love to make models, to simulate, calculate, predict, but ocean currents resist easy understanding. They shift with winds, they respond to the moon, they adjust to seasons, storms, and subtle temperature changes. They twist through underwater mountains. They split, merge, ripple, and reorganize. A computer may capture a moment, but it cannot capture the soft unpredictability of water moving through a living planet. Currents are patterns in constant motion, never exactly repeating, never entirely known. Their complexity is part of their beauty. Though unpredictable in detail, currents leave traces, clues that oceanographers learn to hear. A buoy lost at sea, a small boat adrift, a missing instrument, even clues in search and rescue missions. All can sometimes be traced by studying the patterns of flow, by looking at how a current bends or where an eddy forms. Scientists can estimate where an object might drift and where it may eventually appear. In this way, currents act like quiet detectives, guiding searches, offering hints, revealing answers through the gentle logic of moving water. Currents carry life as readily as they carry leaves or bottles. Sometimes, tiny creatures drift into places they have never been. A crab larvae from one coast may settle on another far away. A seaweed fragment may anchor itself in a new bay. A microscopic organism may find unfamiliar waters suddenly suited to survival. Most of these travelers cause no disturbance, but some become invasive, outcompeting local species, reshaping food webs, altering habitats. It is not malice, it is simply the sea's openness, its willingness to carry its passengers anywhere the water flows. Currents are pathways not just for natural migrations, but for the accidental wanderings of life. When oil spills into the sea, a sorrowful wound on the water's skin, the first question scientists ask is, where will the currents take it? Because the shape of a spill, the direction it spreads, the wildlife it endangers, the shorelines it reaches, all depend on the movements of water. A cold current can slow the spread. A warm one can accelerate it. A swirling eddy can trap oil like a silent whirlpool. A strong coastal flow can draw it quickly toward land. Currents do not create the damage, but they guide its path. And so, in moments of crisis, we listen to the sea's patterns with heightened care, reading its motions like a warning map. There is a poetic truth whispered among oceanographers. Currents are the memory of the wind, because water remembers. A strong wind pushes the sea for hours, and even after the air calms, the water continues to drift in the direction of that vanished force. Days later, the current may still carry the signature of a storm long past, a trade wind long quiet, a monsoon that has already moved on. Currents hold the momentum of winds the way sand holds the warmth of the sun. They carry the memory gently, slowly, letting it fade only when new winds write their stories on the surface. To watch a current is to read history written in water. For all we know, for all we observe, record, and study, the ocean remains full of secrets. Some flows appear where none were predicted. Some vanish into deep canyons, traveling unseen for years. Some warm unexpectedly. Some cool in ways we still do not understand. Some eddies spin in perfect circles, never revealing what triggered their formation. Even the largest currents shift and pulse in ways beyond our full comprehension. Ocean currents are one of Earth's oldest mysteries, not hostile, not concealed, but simply too vast, too gentle, too ancient to be captured in simple explanations. They are the ocean's silent poetry, lines written in motion, verses carried across continents, stories told not in words, but in drifting blue. And as long as the ocean exists, it will continue to move, slowly, softly, in ways both knowable and forever beyond reach. Because mystery is part of the sea's nature. And the currents, with all their hidden quirks and tender oddities, are the sea's quiet reminder that wonder is never far beneath the surface. And now, as we drift towards the end of this quiet journey, you might feel the gentle echo of everything we've wandered through tonight. The warm ribbons of surface currents, the deep, ancient rivers below, the drifting lives carried softly across the sea, and the subtle breath of climate shaped by waters that never truly rest. The ocean is vast, but its movements are tender. Currents glide with patience. Eddies bloom and fade like passing thoughts. Warmth travels north, coolness drifts south, and life follows these pathways with trust older than memory. In every quiet shift of water, the ocean carries stories of connection, of balance, of mystery still humming softly in the blue. As your evening settles, you can imagine those long, wandering currents continuing their journey around the planet, unhurried, unbroken, endlessly weaving the ocean into one breathing whole. If you'd like, let your shoulders loosen now. Let your jaw soften. Let the breath flow in slowly and out even slower, as though your own rhythm is moving with the calm, steady drift of the sea. You are safe. You are held. You can rest. Thank you for drifting with Dreamy Science Stories tonight. May the quiet of the ocean follow you gently into sleep, and may your dreams move with the same soft, endless motion of the tides. Good night. Sleep deeply, sleep peacefully,